Hello world, I'm Solve Hard Problemo, and today we are going to solve third LeetCode problem from Programming Skills study set, which is find the index of the first occurrence in a string. Let's get started. So, what we have here. Given two strings needle and haystack, return the index of the first occurrence of needle in haystack or -1 if needle is not part of haystack. So basically, we have haystack, the big string, where we have to search, and the small string needle where we have what we have to search. So basically, we have to return the index of first occurrence of this string. So we have to return first occurrence of string needle in haystack. So here in the explanation we have word set, which occurs at index 0 and at index 6, and we return the first occurrence of this string. So yeah, basically we have these two examples here, and the second example just shows us that if we don't have such string in haystack, we just return -1. Everything is basic. Okay. So in the retrieval, what questions might appear is what constraints tell us here. Why the problem is easy one, because haystack length and needle length is between 1 and 10 in 4, which is 10,000. So it means that both strings cannot be empty. And haystack and needle consist of lowercase English letters, so it means that it's from A to Z, so nothing more than that. Okay, that is understandable. And as I already always do, what I do is try to imagine a real-world case scenario, and in this case, this problem can be think as we have a big book page as haystack, and we are looking for a small word like cat inside this page. So, and what we will do, we will just try to find this word inside the page and go through this 3-letter spell. And if we not, we just move one step to the right and try it again. And when we find the word, we'll return the position. And if not, we'll return -1. Yeah, so we have a page and we have to find out a word in this page. So this is a real world case scenario. So for this problem, we basically have 3 possible solutions. And we have 3 of them as straightforward approach, built-in, and KMP. I'm not going into details about the straightforward approach and built-in, as I will just quickly review it, and we will just try to dive into our today's algorithm, which is Knuth-Morris-Pratt algorithm, and we will try to solve this problem with this solution. So, but quickly reviewing these approaches, in the straightforward approach, what we have. As we already said before, we have haystack, we have needle, the strings, and haystack is as a long train, and needle is like a small train. And so we want to find where the small train first appears inside the big train. So, and the plan for the straightforward approach is just go and take a small train and put it into the big train and try to check if, for example, set is a small train and set is a big train. And we just take small train, put it to the big train and go over and check if we can find this string. And yeah, basically here it locates in the first index, so index 0, you'll just return this. And as I said, we'll just start at the beginning. If it doesn't match, we will just go one step and try again. And this is the example. For example, we have word hello, and we have needle double L, sorry. And from the first from the first iteration, we'll just check HE and double L, and it's not equal to it. So we'll go one step right and do the same until we'll got what we need and return this index. Probably the complexity for this would be O n multiplied by m, as n will go to each possible number of characters in haystack that we need. So n possible ways, n times, and we'll compare it m as the length of needle or length of string in needle. So it's O n multiplied by m, and space complexity is m. But yeah, in Python, it temporarily allocates memory for slicing. So basically, it would have memory of OM, but never mind, we will not gonna dive deep into all details of straightforward approach. For the built-in approach, what we have here, we have a function find in Python, which is a part of Python. So we will use it as haystack find needle, and it will also do the same thing. It will just search inside haystack and return when it finds a needle, it will return the start index. And so basically, time complexity for this approach would be ON. So it's usually close to ON, I mean, very fast in real life. So in Python, we use inside in the hood, it will run the CPython, which is used a mix of algorithms as fast search plus two-way for long enough strings. And we also gonna not deep dive into these algorithms, maybe later in some other videos. So, and worst case can be ON, also ON multiplied by M in the naive approach. And for the two-way branch, it's ON plus M. So basically this is it. Straightforward and built-in approach. And today, what we're gonna do, how we will solve this problem, by introducing KMP, which is Knut-Morris-Pratt algorithm. And yeah, this algorithm works here in this problem and help us to a little bit optimize our solution, our straightforward solution, where we check for string from the needle in the haystack, and if we don't have, if it's not worked out, we just start over again and always do this, do the same steps. And what KMP actually helps us, it builds the LPS array, and it's also known as prefix function in some books. And LPS, it's the length of the longest proper prefix. There is also a suffix. What is it? Prefix, it's basically starting part of the string, and suffix is just the ending part of the string. So when we have, for example, as in this problem, we have a big word and we have small word as a needle and haystack, and in the normal way, we just put the small word at the start of the big word and check letters one by one. And if it doesn't match, we move small word one step and try again. And KMP, as we always do, just our imagination, our thinking, tell us, wait, I already learned something from the small word, so I don't want to restart from zero every time. So what we do, we have a helper chart, which is LPS, longest prefix suffix. So this chart, what it will tell us if I got a mismatch, how far can I slide the needle without losing the good work I already did. So yeah, and basically it's just like a cheat sheet of about the needle. And we will use this helper chart when we search from this string in the haystack. And when something goes wrong, we don't restart, we just jump through the what we already have. And here I have two examples of this part. So basically, you would think, what is LPS? And I mean, how actually it works. how we do this, but here I'm not gonna go into details as we don't have enough, like a lot of time to process everything here. And I will just maybe later in some videos I will do one more video about Knut Morris Pratt algorithm, and there I will explain actually how LPS is built. But here, what we have, for example, we have needle AB, and LPS for AB is 0, 0. So when we build this, we have no repeats. So just basically, I think we have here also the example where we won't repeat. So here AB, LPS for AB is 0, 0, and haystack is XAB. And we try to do try and match it. So A is equal to A. Yes, A is equal to A. Good. I mean here, A is equal to A. So it matched, so it's good. And haystack has X here in the next needle expects B, so mismatch happens. And now here J becomes 0. We will restart needle. We'll restart needle from the beginning because we don't have. So our LPS is 0, 0. It means we don't have actually in needle. We don't have the same prefix and suffix. Yeah, basically this is it. And because we has no repeating pattern, we will just restart the case. But here, if we have a needle AB AB and our haystack is AB AC, it means that when we will go through this, we have the same pattern ABA ABA. But of course, B is not equal to C. This is mismatch. But when we will go through and want to check it one more time, we don't want to repeat it from the beginning to check also these AB, ABA, because we already did it. And what we have, we'll just store it, and then we'll not restart. We can keep one character A that already matched. So this is basically how it works. And if you don't get the idea, you can just comment it down below, and I will try to create one detailed video about this. But basically, let's now move into the solution. It works now. Here, here's the code. We just have an M with a length of haystack and needle. Then we check if M is more than N, we just return -1 because needle cannot be more than the length of needle cannot be more than the length of haystack. And then we create an array of LPS of M as of needle. We just check the prefix. So actually, basically, for example, AB AB. What actually is LPS for fast way? Here we have A B, so the LPS will be 0, 0, 1, 2. As it first is with 0 because from A we don't have a prefix. There's also the same as suffix. Sorry. Then we will check AB. B and B. AB is also, we don't have the same pattern, so it would be 0. Then ABA, so A is equal to A, so it means that prefix is the same as suffix, so we will increment it by 1, so we have 1 pattern. And AB, it means that if we have AB and we have also AB, which means we have the same prefix and suffix. So AB, the last one AB, and the prefix is AB, so it's the same. And the length of it is 2. That's why we have, this is how actually LPS builds. So comment down below if you interested in solving LeetCode problems. Just also try to do it by yourself. And go with me to go through programming skill set, study set in LeetCode. So see you tomorrow. Goodbye.